In the world of physics, light can be thought of as a wave, but is also quantized in the form of a photon. Multiple waves may interact with each other, but can a single photon interact with itself? To answer this question, we must take a look at a device called an interferometer, a series of beam splitters and detectors that is used to measure the interference of light with itself. The beam splitters are specially silvered mirrors, meaning that they transmit and reflect some of the light. To understand how the light moves through the interferometer, we must create a vector state for the photon that tells us its position. The vector 1, 0 will signify a photon in the upper beam, whereas the vector 0, 1 will mean a photon in the lower beam. Each value in the vector is a probability amplitude that, when squared, will tell us the probability of the photon being in a certain position. When the photon passes through the beam splitters, it may either be reflected or transmitted, and it has a probability of being in the top or the bottom beam. Mathematically, the beam splitter is represented by a matrix that changes the original photon vector through matrix multiplication. The numbers within each matrix depends on the balance of transmitted and reflected light, but we will use two beam splitters that split the light evenly, given by these two matrices. If we send a photon from the bottom beam, initially 0, 1, we can see how the vector changes through the beam splitters. In the interferometer, the photon exists in a superposition of states. It has a probability of being found in the top or the bottom beams. As the photon passes through the interferometer, we can see that the photon will always come out in the top beam. However, if we block the lower beam in the interferometer, the photon will give equal probabilities of being found in the top and bottom beams. Now suppose that instead of a block, we have a bomb that explodes using a photon detector. If the bomb is a dud, the photon will be able to pass through it and the system will behave like a regular interferometer. However, if the bomb is live, it can absorb the photon and explode. A live bomb will act like a block. If the bomb is a dud, then the photon will always come out on the top beam. If the bomb is live, it will absorb the photon and explode half the time. 25% of the time, the photon will be found in the upper beam, and 25% of the time in the lower beam. Therefore, if we find the photon in the lower beam, we know that the bomb must be live, and we haven't exploded it.